this is Julie. Just teaching you about the phase diagram today. Yay! Phase diagrams are pretty simple at first. The general idea is that for substances like water, for example, there are different mediums. We like to say there's the liquid phase, solid, ice, and gaseous, steam. Now, these occur at various pressures and temperatures, or the combination of both. And since this is science, the science of cooking, we're going to talk about it in Celsius, not Fahrenheit. So, for example, at 1 atmospheric pressure, because that's what we're at here in Boston, lovely Boston sea level, we will move across the pressure plane to solid, ice. And like we know, winter's coming, which means that when it drops down to 0 degrees in lovely Boston, we have ice. That would be a 0, and the degree sign is in its way. But anyway, 0 degrees Celsius. Now, on the other hand, if we kept moving through, now it's melted as we cross over into the liquid. As you can see, everything at 1 atm from here to here is liquid. You can tell this because we're going through the liquid region. Just to highlight that quickly. This area is liquid. Liquid. Now, we go back to here. At this point, at 100 degrees Celsius, pretty simple to remember, you get gas. Yay! Steam. And as we remember, steam is more painful than boiling water. So you know for your exams. Keep it in mind, folks. So, this is the basics of a phase diagram. Let's go into it a little deeper. So here's our next phase diagram. But now we're going to talk about things like the Rotovap. So, with the Rotovap, let's go pink. Nope, lavender. So if we have a Rotovap and we're at 1 atm here on Earth, or Boston area, the Rotovap helps bring us down in pressure. Let's redo that. Sorry, folks. Intermission. So normally we're at 1 atm. The Rotovap is a cool machine that brings the pressure down. So let's say it brings us to 0.5 atms, for example. Well, here at 1 atm, if we go here, pop up, and solid, again, we're still at 0 degrees. But, and we go here, through the liquid phase, all the way to the gas. This is still 100. Now go to the drop point. Here at 0.5, as you can see, there's a shift. If I go here, it's still at 0 degrees C. But, on the other hand, if I keep shifting over, as you can see, there's much less time for there to be liquid because already at here, some arbitrary temperature, we're going to call it X, it's already turned into a gas. As you can see, there is a big difference between the 100 and temperature X. And it's all due to the drop in pressure. So remember that if you're using something like a Rotovap, which drops pressure, everything cooks, water boils off, turns into a gas at a lower temperature than 100 degrees Celsius. This helps prevent damaging cells, for example, cell walls in food, like strawberries. Next phase diagram. This time we're going to talk about the pressure cooker. It's so awesome. Much older than the Rotovap. So again, let's start with, we're here, Boston. Wow. Actually, I'm going to do the opposite this time. Here in Boston, 1 ATM. But this time, in a pressure cooker, you increase the pressure. Note the hint in the name. Let's say brings it up to 1.5 ATM. Arbitrary. Again. So, here, 1 ATM crosses over to solid, 0 degrees Celsius, super exciting. If we go up to 1.5 ATM, same deal, 0 degrees Celsius, super exciting. Now, cross over to the gas, per usual, 1 ATM, atmospheric pressure. Go down here, 0 degrees Celsius. This is, again, Boston. Now, inside our pressure cooker, where it's 1.5 ATM, it will go again to some temperature, which I'm not going to name, except as Y. That here is where it turns off. Now note again that there's a big difference, or at least a difference, between the temperatures here. So at a higher ATM, water will boil off at a higher temperature, or higher pressure, I should say. And at lower pressures, water boils off at lower temperatures. So, for example, if you're here, this means that, let's say you put meat inside of a pressure cooker and water boils off at a higher temperature. Well, you're likely to lose less water inside your meat because it would have to go much higher than 100 degrees Celsius for the water to boil off, and therefore, first of all, you have more energy in your system and your meat's going to cook more quickly, but also it helps retain some of the water in your meat, making for more tender, delicious treats. That's Julie's quick blurb on the pressure phase diagram.